Hi guys, welcome back. This is Greg from Wizarden. Welcome to part 2 of the Spring Boot and PostgreSQL mini-series. In part 1, we built and ran a Spring Boot application with PostgreSQL. If you already have a Spring Boot server that you're looking to deploy to AWS, you can still follow the tutorial and adjust accordingly. In this video, we're going to create a PostgreSQL server in AWS with RDS. We're going to connect our local PGAdmin to the RDS database. Afterwards, we're going to connect our local Spring Boot server to the RDS database as well. We're going to build our Spring Boot server and upload it to an S3 bucket. We're going to create a Linux EC2 instance. We're going to configure our user and IAM permissions. Afterwards, we're going to run our Spring Boot server in AWS. Finally, we're going to clean up our AWS RDS and EC2 resources. Let's get started. In this section, we're going to create our PostgreSQL database on AWS. So as you can see now, I have signed into my AWS console. Just a note here, as soon as you create your database or any other AWS resource, you will be charged. So you can reduce charges by stopping your database or any other service when you're not using it, or you can simply delete it and clean it up when you're done your testing. So we're going to click on RDS, DB instances, create database. We're going to select PostgreSQL, and we will do standard create. Engine version is fine. We will do free tier. Database identifier, we'll call it Spring Demo DB. Master username, Postgres is fine. We can either have our credentials in Secret Manager or self-managed. Secrets Manager would be better for production because it'll rotate your password for you. But just for simple testing purposes, we're going to do self-managed. We're going to enter a master password. For instance configuration, DBT4G micro will be fine for what we're using. General purpose SSD 20 gigabytes, that'll be fine as well. Connectivity, choose whether to set up a connection to a compute resource for this database. So we will not set this up at this point, and the default VPC is fine. We are going to turn on public access just because this is a learning series. In production, you wouldn't want to turn on public access. You'd want only resources in your VPC to access your database. Or if you're putting any sensitive information, don't give public access. But we're just doing learning stuff, and it's going to make it easier to add public access. So VPC security group, we'll choose existing default availability zone. For testing purposes, it doesn't matter. You could change that if you wanted to match some other resources. RDS proxy, we're not going to use. Certificate authority, just leave it at default. Additional configuration, database port is fine. Database authentication, we use password authentication. For monitoring, we don't really need this just for our testing purposes, so we're just going to unselect that. And we hit create database. And it'll suggest some add-ons. For our training purposes, we don't need them. And you can see here now it is creating the database. So what's going on behind the scenes is AWS is provisioning different resources, such as like an EC2 instance, Elastic IP, storage. So it's provisioning them, setting them up, and then it's going to write the database and run it on the server behind the scenes. And once it's ready, it'll let us know. So it looks like our database was successfully created. So if we refresh here, see status, configuring enhanced monitoring. In a few moments it should go to ready or available. Alright, so now we can see it's available. So it ran the workflow, created a backup at the start, and workflow is completed, so we're ready to go. You can also click on View Connection Details here. So you can see your username, master password, endpoint. So we're going to note these and we're going to use them to connect PGAdmin to our database. Okay, so now we're going to register the database in PGAdmin. So you're going to right click on servers, register server, call it DB demo in AWS. So we're going to go to connection. For hostname, we can go back to here, we can hit the view connection details, and we're going to copy and paste the endpoint. Port 5432, maintenance database, username is Postgres, and then enter in a password here. And we'll hit save password and then hit save. And now we have connection to our database in AWS. Okay, now let's connect our server to the database in AWS. So we're going to go back to application properties. We're going to copy our endpoint and we're going to paste it on top of localhost. If your username or password changed, update those as well. And we're going to run our server. Okay, perfect. So now we're going to do a test run in Postman. So we still have local server running on localhost, our database is in the cloud, and we're going to send the same body here, but to the cloud. And it looks like it was okay. If we open up PGAdmin to our demo database in AWS, we can go to tables, we can see game user was created, and you can view edit data. And perfect. We have our data being written to Postgres and AWS. Alright, so now that we have our server updated with the new application properties, we're going to rebuild our server. So we're going to go to terminal, Gradle build. Perfect, so that's built successfully. So we're going to go to libs, we'll right click this, and where's the open here? Open and Explorer. So then we're going to go to back to AWS. So we're going to go to, we'll just type S3 into the search. We're going to go to S3. We're going to create a bucket. General purpose bucket name will be Spring Boot Server Object Ownership. We'll do the recommended. Lock all public access, that's fine. Bucket versioning, I don't think we're going to need that right now, so we're going to hit just leave it as disabled. Default encryption, bucket key, that all looks good to me. And bucket name not available, so we'll call it Spring Boot Server Wizard and Demo. So this has to be unique across AWS, so we'll create bucket again. So we have Spring Boot Server Wizard and Demo. Click on that, and we are going to drop in our build into the bucket and hit upload. Alright, so now we have our server application in S3 being waited to be planted onto an EC2. So in the next section, let's create that EC2. Okay, so in this section, we're going to create our Linux EC2 server, which is going to run our Spring Boot application. So in search, we can just go to EC2. We get instances, launch instances. So name, we can call this one Spring Boot Demo Server. We're going to use, we'll do Amazon Linux for the machine image, 2023. Architecture 64-bit. That all looks pretty good. T2 micro. That's free tier as well, so that's fine. We're just doing testing. So key pair login. Select. That's a security group. VPC. Create security group. Yeah, well, yeah, we can create a new security group for this instance. That's fine. Allow SSH traffic. That's fine. Allow HTTP. So we will allow traffic from the internet. Typically in production, you'd probably want to have some sort of load balancer in front of your server, so it's not directly connected to the internet. But for training purposes and to keep this series a little bit more brief, we'll just connect directly to the EC2 and send traffic to it. Configure storage, 8 gigs is fine. We won't need any of the advanced details for this one, so we're just going to hit launch instance. So successfully initiated the launch of the instance, and there's EC2 ID here. So if you go back to instances, we can see that it's already running. Great. All right, so let's set up user and roles. So when we log into the EC2, we can copy that copy from the S3 bucket. And just a reminder here that you will get charged as long as this server is running. So to reduce the charges, you can always go to instance state stop instance. This will stop most, but not all the charges. You still get charged for like storage and IP and stuff like that. And then if you want to stop all the charges, you can just delete the instance when you're done. Let's create our roles and set up, get our user ready for configuring the user onto the EC2 and copying from the S3 bucket. So if you go to users here, we'll create a new user for this. We'll call it demo user. We're not going to provide access to the AWS management console. So we can add user to group, create group. We'll call it demo group. And we will add this user to demo group. And we'll create user. So now we have this demo user here. We need to add some roles to him. So let's click on him and we will add permissions. And we're going to attach permissions directly. So we'll give Amazon EC2 full access. And we also need to give S3 access, add permissions, attach permissions directly, S3 full access. All right, now this user has EC2 full access, S3 full access. So we're going to configure this user in the command line on the EC2. So one more thing we need to do is security credentials. We're going to hit create access key. So we're going to use this to, it's kind of like logging into the terminal on the EC2. So basically we give our keys, terminal knows, okay, this is the user that's on the command line, and it's going to check when we send commands like, okay, does this user have permission to do these things on this EC2 instance and access to S3, etc. So we're going to create access key, avoid using long term, consider the use cases and alternatives. So we're not going to do an alternative. We'll hit other and description tag value demo. key, and we'll create access key. So you do need to copy these down, the access key and the secret key, because we are going to use them in the next section. So I'm just going to copy this to my notepad, and same with this one here. So this is the access key and secret access key, so you need both of those. Bring to boot demo server, click on it, click connect. I think we're just going to try this connect using EC2 connect, and then we'll go here. Alright, so now we're inside the EC2, we have the terminal. So first thing I want to do is hit AWS configure. So this is the access key from the last section, right? So it's basically asking us, okay, what user is going to be, you know, accessing this EC2 and writing commands on it. And so I'm just going to enter the key, and the secret access key as well. So we will also type that in. So now we're ready to configure and install our server. Default region name is fine, default left at 9. And now we're configured with our AWS user and ready to run some commands. So we're going to copy from our S3 bucket to our current directory, our web server. So AWS S3 copy cp s3 : / and then enter in our bucket name and space period, and then we're going to hit recursive, so it just copies everything in the bucket, which is only a web server. Perfect. So now we can see in the directory we have our web server here. So I don't think Java is pre-installed on this Linux, but we can try to just run our web server as is, and we'll see what happens here. So Java command up front. Okay, so we're going to need to install Java on this server as well. Okay, so let's try installing. We'll do Java 17 from Amazon Gradle on our EC2 instance. So we'll do sudo yum install Java 17 Amazon Gradle. Yes, it's okay. Perfect. Now let's test it with the Java version. Oh, it looks like Java is installed. So let's try to run our server again. Perfect. So now we have our server running on our EC2 instance. Okay, so now let's do a test with Postman and see if we can, send a request to our server here. So we're going to go back to EC2. We're going to copy the public IP address, open up Postman, going to replace localhost with the public one, and let's try to insert a user. We'll do test user 2. And yeah, so let's send the request here. And we timed out. Okay, so let's just double check our EC2 if we have incoming traffic load on the proper port 8080. So let's go to select our EC2, we'll go to security groups, edit inbound roles, add role, custom TCP, port range 8080, CIDR block 0000, save rules. And then let's go to Postman here. Send a request again. And perfect. Test user 200 OK. A test user here. If we go back to PGAdmin. Yeah, so it wrote to the database. So there you go. So we connected EC2 in the cloud to our database in the cloud. So it's just kind of a simple setup. For production, you definitely want to have a more robust and secure setup, not allow public access to your database. And for your server, you probably want to also not allow public access and have some sort of load balancer in front of it. And in the next section, we'll just clean up our resources. So in this section, we're going to clean up our resources. So this is the EC2 instance we had for our demo server. So we're going to select it, and we're going to do actions, instance state, terminate, delete instance. It does give you a warning here on an EBS backed instance. The default action is for the root EBS volume to be deleted, which is fine. And we'll hit terminate. And we can see that it's been successfully terminated. And we're also going to terminate our RDS server. So we're going back to RDS, DB instances, Spring Demo DB, actions, delete. We don't need a final snapshot in our case because we don't need to save the data. We don't want to retain any automated backups. So you have to click that, acknowledge that upon instance deletion, automated backups, including snapshots and point-in-time recovery, will not be available. That's fine. And we'll enter and delete me here. Okay, so we successfully deleted our instance. There's a few other things I'm not going to show, but I'm going to clean up the user I created and delete that as well. Also delete your security group as well. And you can always check with AWS if you're being billed for anything minor like a security group or Elastic IP. But for the most part, most of the heavy hitting charges should be cleaned up. Don't forget to like our video and subscribe to our channel, and also join our Discord developer community.